Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to be wrapping Chapter 2 up, and we're going to end on a pretty good and easy note of graphing linear and absolute value inequalities. The good news is that we have already learned how to graph linear equations, and we've already learned how to graph absolute value equations. Today we're going to learn how to graph linear inequalities and absolute value inequalities. But before I move on and show you inequalities, let's just have a quick little review or examination of y equals 3x minus 2. This is, of course, a linear equation. The y-intercept would be -2. My slope is 3 over 1, so I'd go up 1, 2, 3, 1 to the right, up 1, 2, 3, 1 to the right, backwards down 1, 2, 3, 1 to the left. And I go ahead and connect the dots, and that is my line. That should be pretty self-explanatory at this point, and everyone should know exactly how I graphed this equation. Are there any questions on determining what the y-intercept was, how or why I graphed it, determining what the slope was, and how or why I used the slope? Pretty simple, right? Okay. So, how does this apply to inequalities? Well, when solving linear inequalities by graphing, there will be an infinite amount of solutions. When you have a line, okay, the solutions are on the line. But when you have an inequality, a linear inequality, you have an infinite amount of solutions. So you must shade your solution set or solution zone based on the boundary that you're given. Now, let me explain how this works. If I have y is greater than x, I know that my slope is right here. It's positive, so I'm going up. If I want to shade y is greater than, you look at the graph and it's going to be shaded above the graph. So if it's greater than, you shade above the graph. If you have y is less than x, then you're shading below the graph. Sometimes people don't understand that, so I give you another way to try to understand that. Look for the y-intercept. If y is greater than, well then all of the shading is going to be above the y-intercept. If y is less than, then all the shading is going to be below the y-intercept, hence going down. If I have a negative slope, y is greater than negative x, or y is less than negative x, I have this boundary here. Okay, here's my y-intercept. So y is greater than, I shade above the line or above the y-intercept. If I have y is less than, I shade below the line or below the y-intercept. Now, if you noticed when you had greater than or less than, you did not have a solid line. Whenever you're dealing with greater than or less than, you are going to use a dashed line to graph the equation. It is a dashed line because the points on the actual line itself are not solutions. It's everything either above it or below it. And then the same exact shading qualities work for when you have x is greater than or equal to, or I'm sorry, y is greater than or equal to, or y is less than or equal to. Same exact shading rules. The only difference is that when it's a greater than or equal to or a less than or equal to, as you can see here in the graphs, it is a solid line. Does that make sense so far? Please ask questions right now, guys. Not tomorrow, not after we've taken the quiz, not after I've already gone over the homework, but right now. Can I answer any questions at all, please? And thank you. Okay, we're going to take that as a no questions. So let's graph this. Y is greater than or equal to 2x minus 3. What is my y-intercept here, gentlemen? Negative 3. So I go 1, 2, and negative 3. Great job, gentlemen. And then what is my slope? So I'm going to go up 1, 2, 1 to the right, up 1, 2, 1 to the right. Let's go backwards. Down 1, 2, 1 to the left, down 1, 2, 1 to the left. And is this going to be a solid or a dashed line? This is going to be solid because it's greater than or equal to. Very good, gentlemen. And now the piece de resistance, the main course here. Am I going to shade above or below? Above. Now, I have a little suggestion and request. Okay, it's going to make your life easier. A lot of times people just show you, oh, just shade it. Okay, that works, but not really for me. What I want you to do is show me that you shaded it using straight lines. And the reason why I want you to do that is because next chapter I'm going to add another equation here. And I'm going to have to shade that as well. Do you see where you get the checkerboard there? That's clear, isn't it? That's where your solution's going to be. So that's why I'm asking you now, please, when you shade, please do not shade as just a scribble, but go ahead and shade using lines, please. Yes, sir, my brother. Thank you. Okay, so that sounds good. Yeah, just use straight lines, and thank you so much. I appreciate that greatly. Okay, let's move on. Sometimes you're going to be dealing with word problems, and when you're dealing with word problems, you need to know what some words mean. When you hear at most, it is less than or equal to. For example, Mr. Morrow is at most 45 years old. That means he's 45 or less than that. So whenever you hear at most, it's less than or equal to. At least is greater than or equal to. For example, I could say that everyone in this class is at least 15 years old. That means you're 15 or older. So at most is less than or equal to. At least is greater than or equal to. Now, when you see the word less than, that means subtraction. But when you see the phrase is less than, that means it's the less than sign. So if I were to tell you x less than 5, that means 5 minus x. Remember that less than means switch. But if I tell you x is less than 5, that means that x is less than 5. Big difference. Please be careful and cognizant of that. Is more than, same logic, but you have the is in front of it. The is indicates that you have an inequality sign, and is greater than or is more than, it's a greater than symbol. Does that make sense? Great. So let's graph these bad boys. X is greater than or equal to negative 2. What kind of an equation, what kind of a line is x is greater than or equal to negative 2? It's a vertical line. Very good. It's going to be solid as well. So let's go x is greater than or equal to negative 2. So am I going to go to the left or to the right of this one? To the right because it's greater than. Excellent job, gentlemen. Now, real quick, let me do, all of these are equal to as well. So let me just do something real quick. Give me 1 second, gentlemen. Okay. B, y is less than 2x minus 3. What is the y-intercept? Negative 3. What is the slope? Up 1, 2 over 1 to the right, up 1, 2 over 1 to the right, backwards, down 1, 2, 1 to the left, down 1, 2, 1 to the left. Dash or solid?
Solid. No, it's
Dashed. Dashed. Above or below? Below, very good. And there it is. Very good. See, when you graph it with lines that are straight like that, it's very therapeutic. Now, y is less than or equal to 3. What kind of a line is that? Horizontal. So is it going to be solid or dashed? Okay, y is less than or equal to 3. Above or below? Below, because it's less than. It's below. Okay. What must I do for D first? Thank you. Solve for y. Very good, my man. So I'm going to subtract 2x to both sides. So I've got negative 3y is greater than or equal to negative 2x minus 3. Divide by a negative 3. And what happens to the inequality when I divide? Very good, gentlemen. Good job. So y is less than or equal to now 2/3 x plus 1. What's my y-intercept, gentlemen? 1. What is my slope, gentlemen? Up 1, 2 over 1, 2, 3. Up 1, 2 over 1, 2, 3. Backwards down 1, 2 over 1, 2, 3. Backwards down 1, 2 over 1, 2, 3. Solid or dashed?
solid.
Above or below? And there you go. Questions on graphing linear inequalities. Please, my brothers, please ask me now so I can help you. Thank you for your honesty.
Why did you solve for y like y not x?
Why did I solve for y and not x? Thank you very much for that question. We solved for y because we learned the formula y equals mx plus b. Now, on the first one, it was x is greater than or equal to negative 2 because that's not a function. That's an x equals equation, which we talked about when we learned about linear equations. Thank you for asking, though, sir. I appreciate it greatly, and I appreciate you caring. Any other questions? Okay. Now, how would I find the equation for this graph? Yes, sir. Work backwards. Okay. So I've got to find a y-intercept, and I've got to find a slope, and we also got to determine if it's a greater than or equal to or a less than or equal to or a greater than or a less than. It's going to be a greater. Very good. So we know it's going to be a greater because it's dashed and it's shaded above. Great job. What's my y-intercept, my brother?
4.
Yeah, 4. Very good. What's my slope? Again, slope from one perfect point to another perfect point. Negative 1 over 3. So now let's go ahead and put this together, my man.
Y is greater than negative 1.
Y is greater than negative 1 over 3 x plus 4. That is spectacular. Well done, my brother. Does that make sense to everybody? That means everyone in here is valid. Everyone in here is worthy of getting their questions answered. Please ask now, though, my brothers. Yes, sir. Thank you, my man. Yeah, it's negative 1 over 3 because we're going from left to right always. So when I go from left to right always, I went down 1, and I went 1, 2, 3 over to the right. So that's negative 1/3. Thank you so much. Does that make sense, gentlemen? Promise? Okay. Any other questions on this before we continue, my brothers? Thank you. Okay. How about this bad boy? What would the equation to this be? We've got to find the b, the y-intercept, the m, which is the slope. And then is this going to be a greater than, less than, greater than, or equal to? It's going to be less than because it's dashed and it's shaded below. So we know it's going to be a less than. What's the y-intercept here, gentlemen? -2. Very good. Very good. Good job, guys. And then again, we're going from left to right. So I've got to figure out how do I get from this perfect point to, let's see, where's a perfect point here? 1, 2, 3, 4. Yeah, right here. So it's up 1, 2, 3, 4 over 1, 2, 3. Go ahead. Well, what? The one on the x-axis is not. It's not really perfect point there. Let's see. Let's see. Hold on. Let's see. Let's see. Um. Actually, yes, you're absolutely right, son. That is more perfect. So it'd be up 1, 2, 3, 4, 5 over 1, 2, 3, 4. Well done. So my slope is 5/4. So how can I write this equation then, gentlemen? Y is less than 5/4 x minus 2. Fantastic. Does that make sense, gentlemen? Good job. Questions, comments, concerns? Okay. Now, for a party, you can spend no more than $12 on nuts. Peanuts cost $2 a pound. Cashews cost $4 a pound. What are 3 possible combinations of peanuts and cashews you can buy? This is the beauty of linear inequalities because it shows you a multitude of possibilities. So first of all, remember what we always say, whenever we work with word problems, we label the variables. So who do you want to call x this time? Peanuts. Okay. And who do you want to call y? Cashews. Very good. Okay. So then how much do they charge for every peanut? So $2 for every peanut plus, for every pound, sorry, plus $4 for every pound of cashews. And this can be no more than 12. So it has to be less than or equal to 12. Very good. Now, let's go ahead and solve this by graphing. Okay? But no, you're doing great. You subtract 2x to both sides. For y is less than or equal to negative 2x plus 12. Divide by 4. Y is less than or equal to negative 1/2 x plus 3. What's my y-intercept? So 1, 2, 3. What's my slope? Down 1 over 2, down 1 over 2, down 1 over 2, and I stop. Why do I stop right there? You can't have negative peanuts or negative cashews. Yes, sir. I'm going to go over that into 1 second, please. So you have a solid line above or below? Below. So now the question here is, what are 3 possible combinations? Okay, give me anything inside of that area. Okay, you could have a pound of each. You could have a pound of peanuts and 2 pounds of cashews. 2, 1. You could have 2 pounds of peanuts and 1 pound of cashew, and anything else inside of this area. Now, this is one way to graph it. But there's another way to graph it that could have been a lot easier. Nobody mentioned it, though, except for one person. What is it that you were trying to graph? Very good, the x and y intercept. Very good, my brother. Remember what we had said, gentlemen, that if the a and the b are factors of c, then I can use the x and y intercept method. When y is 0, my x-intercept is 6, 6 comma 0. When x is 0, my y-intercept is 0, 3, which is exactly what we had before. 1, 2, 3, 4, 5, 6. And again, it is less than, so I shade below, and there it is. Does that make sense, gentlemen? Thank you. Good catch there, son. Yes, sir, my brother. No, 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 no. You can't put every single possibility because there's an infinite amount of possibilities here. I know exactly what you asked, and that's exactly what I answered. No, you do not. You cannot put every single answer because there's an infinite number of possibilities. Can't you technically get zero point 0.1 pounds of peanuts? Exactly. So no, I will never ask you to write all of them because it's impossible. I will tell you, write 3 solutions, give me 2 solutions, give me 1 possible solution, but I'll never tell you to write all of them because there's an infinite number of solutions. Thank you so much, my man. Thank you for caring. Any other questions before we do the absolute value inequalities, guys? Yes, no, maybe, kind of, sort of? Give me 1 second. Okay, guys. Now, graphing absolute value inequalities. Graphing absolute value inequalities, guys, is really, really simple. You're going to graph just like normal, okay, except you're going to shade. If y is greater than or equal to plus or minus absolute value of x, or y is greater than or just greater than plus or minus absolute value of x, you're going to shade above the vertex. Above the vertex. If y is less than plus or minus x, or y is less than plus or minus the absolute value of x, then you're going to shade below the vertex. It's literally that simple. For example, what's my vertex here? 2, 1. So 1, 2, 1. Bless you. What's my slope? What? My bad. Thank you. I should learn how to pay attention. 2, negative 1. Thank you. What's my slope? So up 1, 2, 3. 1 to the right. Up 1, 2, 3. 1 to the left. Dash or solid? Solid. Now, y is greater than. So do I go above the vertex or below? Above. So it's everything inside of here. Literally. That's it. Yes, sir.
Do you want us to draw the line throughout the whole graph, like at the end, and shade all the way up?
Yeah.
Keep on expanding?
No, just, within reason. You don't have to continue going that way. No. Within reason. If you want to make it more accurate, you do more and more points. We'll do a few more points for this next one. Okay, what's my wrong? You first have to factor out this 2. So when I factor this out, this is a 2 that I factored out. 2 divided by 2 is x, and that's minus 3, and that's plus 2. Now, what's my vertex? 1, 2, 3, 1, 2. What's my slope? Up 1, 2 over 1 to the right, up 1, 2, 1 to the left. Up 1, 2, 1 to the right, up 1, 2, 1 to the left. Dashed or solid? Dashed. It's y is less than, so above or below. So it's going to be below this graph. Those are the solutions. Does that make sense, gentlemen? Yes, sir, my brother.
You have to factor out to do the greater than sign with this.
If you had to factor out a negative 2, the inequality would not change at all. Thank you very much, my man. It's only when you go from one side to the other by multiplying or dividing. And that's it. Does that make sense, guys? Now, one thing I want to do real quick, because you guys messed up on this on the quiz, and I want to make sure that we do it correctly. If I have y, whatever, it doesn't matter if it's an equality or if it's an equation. Absolute value of, let's use this one. And actually, let's make it a little bit more challenging. Let's say this is 1/3, and I have 1/2 x, whatever, plus, bless you, son, plus 3, okay? What do I have to factor out? Okay, so almost everyone understood that part, and I'm very proud of you. However, are you dividing 1/3 by 1/2 as well? You're multiplying. You're not state change flipping anything, guys. You're factoring out a half. So this is 1/3 times the half that you factor out. Now you state change flip that, and it becomes 1. Now you state change flip that, and that becomes 6. But this would be y is less than 1/6 x plus 6. When you factor something out, guys, you're multiplying whatever you factored out to this outside value. You are not dividing it. It doesn't matter if you're factoring out a whole value or a fraction. You're multiplying what you factored out to the outside value, and you're state changing and flipping inside of here. Thank you very much. May God bless you. Have a wonderful day. Thank you for a great class. Hope you learned a lot. Bye-bye.